Question 5, 2022 January CSEC Mathematics Past Paper. This question statistics question, comes under the topic statistics. It says the cumulative frequency diagram below shows information about the distance d kilometers that each of 120 students walk to school on a particular day. Alright, so you have the distance here, cumulative frequency. A, how many students walk at most 1 kilometer to school on that day? Well, not sure where this would be, because nowadays even 1 kilometer, as long as there are buses and taxis, they don't want to walk. Right, they want to take a bus. Even half a kilometer, I've seen them some take taxis. But anyway, this goes up to 3 kilometers. But just before we do the question, remember this is a general form that the cumulative frequency takes. Alright? Because basically you will have the first part of the curve rising up slowly, because you expect in this case many of them would walk few of them live so close to the school. Right, this is the number of students going up. You will find that only a few of them will walk a short distance, and only a few of them live very far from the school. But the bulk of them live within this certain distance from the school. Alright? That's why the shape is generally like that. You have the two extremes at the top and bottom, and then a large number of people or whatever it is crowded in the center, so it rises up very fast. Right? Much larger number of people for a smaller change in distance. What it says here, how many students walk at most 1 kilometer to school on that day? Let us copy and paste this question here. Now, at most means no more than that. 1 kilometer is the most. That's what it's saying, at most 1 kilometer. It doesn't pass 1 kilometer. So how many students? Can you figure that out? Alright, look at this. 1 kilometer, you identify 1 kilometer. From there, you draw a line going up to the curve. Then from where it touches the curve, you project across. Alright? So, you're looking at about this point here. Let's see now. Where is that point located? You know that some of these numbers these values are missing, right? They miss out some of these values, but this would be 10, 20, then 30, 40, 50, 60, and so on. As for these smaller squares, such as this little square here, how high is it? Let's see. How many squares are between 0 and 10? 1, 2, 3, 4, 5 of them. So each small square represents 2 units. Alright? Represent 2 students. Now, how many small squares do you get going up here? 1, 2, it might reach 3. Call it 3. So that would be 6 there. So you have 30, 32, 34, 36. Say it's about 36 then. It's 36. Alright? So 36 students walk at most 1 kilometer to school that day. So let's put 36 there. Alright, what else is here? Using the cumulative frequency diagram, determine an estimate of the median. So you want the median. Now, you must remember how you obtain the median using the cumulative frequency curve. Do you remember? If so, what is the median? Now, let's just erase some of the work we did here. Here now, to locate the median on the cumulative frequency diagram, you go from 0 all the way here, which is 120. Good. Then you go halfway that distance, which would be 60. So from there now, from the 60, you project 2. The curve. Remember what it says. Determine an estimate of the median. That's the median distance. Even though they don't say distance there, it's the median distance. Not the median students, median distance. So from here, where the line projects horizontally from halfway up the cumulative frequency curve, you project from here down to the distance, the x-axis. So right there now, you want to find out what would that value be. All right. You have from here to here 0.5. How many small squares do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 small squares. So what that is suggesting is that each of these small squares is 0.5 divided by 10, which is 0.05. So this now, you have 1. So you have 1 kilometer plus, how much do you go? How many 0.05 do you go? 1, 2, 3, 4, 5, 6. All right, call it 6 plus 0.05, which is one of the small squares, and there are 6 of them. So 0.05 by 6 is going to be, you know that 5, 6 is 30. So here, 5 by 6 is 30. This is 0.05, which is the same as 5 divided by 1 by 100. So 30 divided by 100 is 0.3. Right? So this is showing that this is 1.0 plus 0.3, which is 1.3. You see, it doesn't reach 0.5 yet, you know. It's 1.3. So it looks like 1.3 kilometers. You see that? All right. Now the next thing, they ask for the interquartile range. An estimate of the interquartile range. Remember, you have to remember about your interquartile range business and your quartiles and so on and so forth, right? Now remember, quart, Q-U-A-R-T, it means 4. So quadrilateral has 4 sides. If you have a woman gives birth to 4 children, that's quadruplet. You have 4 quarts make 1 gallon. You have quad core processor. You dual core, you have 2. Quad core means you have 4. What else can I think of with quad in it? Quadrant, right? You have a circle. In trigonometry, you have 4 quadrants in the circle. 1, 2, 3, 4, and so on and so forth. Remember, quad means 4 of them. Alright? Now, the quartile. It means you're going to divide up the cumulative frequency axis into 4 equal parts. 120 over 4 is what? It's 30, right? So, 30, 30 to 60, 6 trees, 6, 3, 2, 6, 32, 60, 33, 90, this would be 90, and 30 by 4, 120. Alright, good. Let me redo this and this. So, you have the 30 here, you have the 90 here. So, therefore, you have Q1, the quartiles, you divide them up. This is Q2, 2 quarters mean half, right? Q1, Q2, Q3, right? First quartile, second quartile, third quartile. The fourth quartile would be 1 whole. 4 quarters make 1, right? So then, remember now, in this case, Q1 is a quarter, which is 25% of everything. Q2 is 50% or half. Q3 is 3/4 or 75%. And then the interquartile rate, call it IQR, would be Q3 minus Q1, which would be within this range here, right? So in this case, Q3 is 90 minus Q1 will be what? 30. So 90 minus 30 is equal to 60. 60 students. So the interquartile range for that, for the cumulative frequency curve. But then, here, what you want is the change. This is 60 students here. But what you want is a change in the distance, the difference, I mean, in terms of the distance walked. So from 30, if you go to the curve, then down, and then from 90 you go to the curve, and then down. Let me do that again. The line got lean. Call it that, right? Now this is in terms of students. This is not what you're interested in here. So remember, this is difference in the number of students here. right? That's 60, which would be 50%. But you want the distance. So what happens here? This is 0.5 plus. How many 0.05 do you have? 1, 2, 3, 4, 5, 6, 7, 8. It looks like this is 0.5 plus 8 of the 0.05. 8 times 0.05 is what? It's going to be 8540 over 104. Right? 0.4, I mean. 40 over 100 is 0.4. So it's 0.5 plus 8 by 0.05. Should write the 0.5 here before. So this is 0.5 plus 0.4, which is 0.9. And then for here now, this would be 1.5 plus what? Call it, the line look a bit lean, but call it one of the small squares, 0.05. So it's 1.55. So therefore, what you're looking at is 1.55 minus 0.9 kilometer, which is what? 1.55 minus 0.9, which is 5, 0, 9, 10, 11, 12, 13, 14, 15, that's 6. So it looked like 0.65. 0.65 kilometers is the interquartile range. The range in distance between here and here. Alright? Alright, that seemed to be the case. Oh, there's a probability business here. Interesting. Alright, let's not copy this. A student is chosen at random. What's the probability that students walk from more than 1.5 kilometers to school that day? More than 1.5 kilometers. Let me just make a note of it here before I forget. More than 1.5. This is what? Part C. Part C. More than 1.5 kilometers. Greater than 1.5 kilometers. The probability that you want. Alright, so the previous work is kind of crowding up the board. Let's erase the board. Okay. So the probability that our students walk more than 1.5 kilometers. Now remember, alright, first of all, before I remember anything, I want you to pause the video and do that calculation for me. Alright, finished. What did you get? Now, let us see what's happening here. Remember, the probability is really how many, the number of the items that you're looking for or you're interested in. Alright? The number that you want divided by the number available. All of them, including those that you want, the total available. Alright, so the probability here now. The probability is going to be how many students, the number of students. Remember, I'm just using the number sign here now, but you must write out everything in your exam. It's just that I don't have a lot of space here. Is the number of students who walked divided by the number of students who are there. The number of students who are there is what, 120, let's say. So it is 120. How many students walk? What they say again? More than 1.5 kilometer. How many students walk more than 1.5 kilometer? Alright? How many students walk more than 1.5 kilometer? Divided by how many students are there. Alright, 1.5 kilometers. How many students walk exactly 1.5? How many students walk 1.5 kilometers? Starting where? Where does it start? Well, you won't really have, maybe you won't find a student who walk exactly 1.5, but we're looking at the information here from the graph, right? So here now, this is what, 80. Each of these small squares was what, 2? So it's 82. 82 of them walk 1.5 kilometers, right? So those who walk, the maximum distance is 120. So the number who walk more than 1.5 kilometers will be 120 minus 82. That's 120 minus 82. 120 minus 82. 0 minus 2, you can't borrow 1 from 2, you get 1. 10 minus 2 is 8. 1 minus 8, you can't borrow 1 from this, you get 0. This is 11. 8, 9, 10, 11. That's 38. Alright? 38 of them walked 1.5 kilometers or more. So the probability then will be 38 over 120. So is what? What's 2 into 38? Half of 38. So this is 38 is 2 by what? 19. 2 9 is 18, 2 and 2. Yeah. 2 by 19. How many 2's do you have in 120? 60 is 2 by 60. 2 cancel 2. So what you have is 19 over 60. Alright? 19/60th. The probability is 19 over 60. Alright. So we have that. It's 19/60th. Alright, now what else they say happen here? Okay. They say complete the table below and use the information to calculate an estimate of the mean distance walked by the student on that day. Alright. We will end the video here and do part D in our next video.